Have you ever wondered how a simple click on your screen can fetch information from halfway across the globe in milliseconds? The internet is often thought of as a vague cloud, but it is actually a massive physical infrastructure. It is essentially a network of networks that connects billions of devices worldwide through a complex web of hardware. To grasp its scale, consider the explosive growth of global internet users over the last 2 decades. Starting from a niche tool for researchers, it has evolved into a fundamental utility for over 5 billion people today. This staggering growth highlights how dependent our modern civilization has become on digital connectivity. Moving into the physical realm, the backbone of this system isn't found in the air, but deep under the ocean. Over 95% of international data is transmitted via submarine fiber optic cables that stretch for thousands of miles. These cables, some no thicker than a soda can, carry pulses of light representing terabits of information every second. Furthermore, these cables connect major data centers, which act as the brain of the internet. These massive facilities house thousands of servers that store the websites, videos, and files we access every day. Without these physical powerhouses, the digital world simply would not have a place to live. But how does data know where to go in this vast ocean of machines? The answer lies in IP addresses, which serve as unique digital zip codes for every device connected to the network. Whether it's your smartphone or a high-end server, an IP address ensures that data is sent to the correct destination. Alongside IP addresses, the domain name system, or DNS, acts as the Internet's phone book. Since humans find it hard to remember strings of numbers like 142.250.190.46, DNS translates easy-to-read names like google.com into those numeric IP addresses. This translation happens in the background every time you type a URL into your browser. Next, let's look at how data actually travels across these connections. Instead of sending a whole file at once, the internet breaks data down into small pieces called packets. Each packet contains a piece of the content, along with header information that tells the network where it came from and where it is going. Crucially, these packets are managed by routers, which act like digital traffic controllers. Routers look at the destination of each packet and decide the most efficient path for it to take. Remarkably, packets from the same email might take different routes across the world and still arrive at the destination in the correct order. To ensure these packets are reassembled correctly, the Transmission Control Protocol, or TCP, comes into play. TCP is like a handshake between two computers. It checks for missing packets and requests them to be resent if they are lost. This protocol guarantees that your downloaded file is an exact copy of the original. However, speed is just as important as reliability, leading us to the concept of latency. Latency is the delay between a request and a response, often measured in milliseconds. While fiber optics are fast, the sheer distance and the number of hops between routers can affect how snappy your internet feels. In addition to speed, security is a paramount concern for modern web traffic. This is where HTTPS and SSL encryption come in, creating a secure tunnel for your data. Encryption scrambles your information so that even if someone intercepts a packet, they cannot read its contents without the secret key. Beyond traditional computers, the rise of mobile data has transformed how we access the network. 4G and 5G technologies use radio waves to connect your phone to local cell towers, which are then linked to the same fiber optic backbone. This allows the internet to follow us wherever we go, from busy cities to remote parks. Step into the future, and we see the Internet of Things, or IoT, connecting everything from refrigerators to streetlights. By 2030, billions of everyday objects will be generating data and communicating across the internet. This massive influx of devices is driving the need for even more bandwidth and lower latency. Moreover, the quest for global coverage has led to the development of satellite constellations like Starlink. By placing thousands of small satellites in low Earth orbit, companies aim to provide high-speed internet to the most remote corners of the planet. This bridges the digital divide for those living far from fiber optic lines. Despite these advancements, the core principles established decades ago still hold the system together. The Internet's decentralized nature means there is no single point of failure. If one path is blocked, the network automatically finds another. It is this resilience that has allowed it to grow into the most complex machine ever built by humanity. To summarize, the Internet is a marvel of both physical engineering and digital logic. It combines massive underwater cables, sophisticated routing protocols, and billions of connected devices to create a seamless experience. Every time you stream a video or send a text, you are participating in this global symphony of data. As we look ahead, the Internet will continue to evolve with technologies like quantum networking and 6G. These innovations promise near instantaneous communication and even greater security. The story of the Internet is still being written, and we are all part of its connected future. Thank you for joining us on this journey through the invisible wires of our world. Understanding how the Internet works helps us appreciate the incredible technology at our fingertips every day. Don't forget to like and subscribe for more deep dives into the tech that shapes our lives.